All right. You get exposed to I'm new to Wyzant and I'm still working on getting some of my equipment to work correctly. I can't get I don't have a good writing tablet and I'm having to draw these things and write these things with my mouse, which is horrible. Anyway, here we go. Got a man on the dock pulling a rope fastened to a boat. The man's hands are 12 feet higher than the point where the rope is connected to the boat, and he's retrieving the rope at a rate of 3 feet per second. So we know that the rate drdt at which the rope, which is represented in my diagram here by r, we know that it is being retrieved at 3 feet per second. The rate of change is and this is a related rate problem. And you're only going to see three types of those in an AP course anyway for calculus, involving angles, and you'll use some kind of trig function, a volume or area kind of problem, and you need to know the volume of, say, a sphere or a cone, uh, and a right triangle problem. And that's what we have here. We've got a right triangle, and we're going to use the Pythagorean theorem, which says x squared in our diagram plus 12 squared equals r squared. And what are we looking for? We're looking for the rate of change of x when r is 20 feet long and the rate of change of r is 3 feet per second. So we're looking for dx dt. That's what we want. All right. So let's differentiate both sides of this equation with respect to time. You're going to get 2x dx dt plus the derivative of 12 squared. What's the derivative of a constant? 0. 12 squared is 144. The derivative of 144 is 0. And on the right side, you get 2r dr dt. And again, we know what r is. We know what dr dt is. We're just going to plug what we know into this equation and find x. That's what we're after. I'm sorry, we're going to find dx dt. Well, I could go ahead and divide both sides of this equation by 2x, and that'll isolate dx dt. So let's just write it that way. We've got 2x dx dt, dx dt equals 2 times r. What's that? That's, well, let's just write it this way, 2r dr dt, because we're going to divide both sides by that 2x. We divided the left, let's divide the right. The 2's are going to cancel. There we go. Let's substitute in what we know. We know r is 20. That's why you write down at the beginning of these problems, what do you know and what are you looking for? We know dr dt, that was given to us at 3 feet per second. Ooh, but we don't know x. But we can figure x from the Pythagorean theorem. We know at the point in time we're looking for dx dt, r is 20. So if we take x squared plus 12 squared equals r squared and substitute 20 in for r, let's just do it up here. We'll have x squared equals, what is it? R squared, which is 20 squared minus 12 squared. Okay, I just subtracted the 12 squared from both sides. And so x, I'm not going to do that math. You can do that math. This is a calculus question. You can solve x squared here, and you're going to get x equals 16. So if I put into my final equation down here, x is 16. I got 60 in the numerator, 16 down in the denominator. You can reduce that to, what is it? Let's see, 30 over 8, 15 over 4. Or what is that? 3 and 3/4, or 3.75. Might look prettier that way. I don't know. Depends on how they want you to produce the answer, feet per second. There we go. Hopefully next time you come around, I'll have a little better handle on how to handle this whiteboard. I apologize for that. Anyway, if you have any questions, contact me. Why not?